Hey guys, we are still on day 2, so we just finished up that first section on building coastlines, and you're getting the different coverages. And just before we create the Quadtree grid and add the zones of resolution. And so, but I wanted to take a minute and just show you where you can get to the data for this lecture and that. So we are working with the Coastal Inlets Research Program, and so on the website, which is cirp.usace.army.mil, this is the main page, and right now we have a link to this webinar series in the upper right hand corner. But if you come in a little while later, after a couple of months, and we've moved on and put some other recent events up there, it may be moved. So if you look under Tech Transfer, under Webinars, there will be a entry for CMS Basics with SMS 13, and it may be a little bit lower in this list, but we can go back and look at this. So if we choose that, we've got another page devoted to this, and where we've basically covered the different topics for each day, and then access to the files. So that would be, day 1, 2, 3, 4, and 5, and these are presentation materials, and this is the data files. And below this is we will have the videos available on the website as soon as we can process those and get those up there. So for now, let's move on to the next portion. And so I will go into the presentation here. So what we previously did, we saved in the 3 after boundary folder, we saved the project, and basically it had the activity classification, the Quadtree generator, basically where we only defined where the domain was, and the boundary condition where we assigned our offshore boundary. And so that's located here. We've also got the cusp shoreline in, and if you also had a image or things like that, we could have those located in this also. So every time you save SMS, whatever you have in this data tree will be there the next time you load it back up. So we'll just go in and make sure that we choose this and bring it into SMS. And it may not look exactly like this, but we can change things under display options and turn things on and off, and I'll go over that a little bit in the demo that I'm going to be doing a little bit later. So here actually is how we can bring in a rectified image. And so you see we have a folder, and underneath that same folder we just were in called image, and it's got one file already in it. It's a TIFF file. It also has a TIFF world file that basically gives some information about spatial things like that, how it's set up. And then there's also a projection file, so that when we bring it into SMS, SMS already knows what the projection is. It's already in New Jersey state plane feet or whatever the actual coordinate system or projection was when we downloaded it. So we can just click this New Jersey TIFF, click open, and it'll bring it in, and you see it's only a small portion of the display here. It may be covered up by your bathymetry, as we showed earlier. You might want to go in and change the transparency for your screen contours so you can see this a little better, all to your liking, whatever you want to see. So I've got this set to about 30 to 35% transparency, and that basically gives me a good blend of being able to see the image and also seeing the bathymetry that I'm working with from the actual scatter data. Another way to do to get images, and this is working now in 1308, but in 1305 and 12.3, the feature, the process that SMS uses to get these dynamic images was broken by Esri. They changed their server on the back end, and so Aquaveo had to go back in and change some of the ways they call to get this information. And so none of this works with 12.3 or later until 13.08. So anyway, so what you would do is basically come down to the lower bar, and these can float. So these actually can be in different places, and often are sometimes. You'll come in there in an odd location. But so don't think it's always going to be down here, but look at the one where it looks like a light bulb. That's for shading, and some other things. We'll be going over some of this in the post-processing. But the last one here is get a dynamic image. So we click that, then it brings up a menu here, so we can choose what type of map it is that we're looking for. And there's a lot of choices here. There's probably 6 or 7 different choices. For the most part, I choose world imagery, but you might want to do a topo map or something else. So choose the one you want, you just select it, click OK, and then it will come in, add another entry to the GIS data for world imagery, and show it. And basically what it's done is it's gone out and gotten the information for exactly your screen dimensions that are showing in your graphics window. And so one of the nice things about these dynamic images is when you zoom in or zoom back out, a lot of times with a static image you'll have bad resolution on that image and it's hard to see. But SMS will automatically, as you zoom out or pan around, it's going out there and it's grabbing the latest tiles that are for that particular zoom level and area. And so it will update the picture for you so that you're always looking at a good, crisp image. So one thing you'll see is actually when you're moving around, this world imagery will actually have a little caveat out here in parens says processing. And so once that's finished, then your image will show up for the new parts of the area or better resolution in the areas as you've moved in. So be prepared for that. This is just saying that there have been some issues and it's been resolved in 13.08. All right, so one of the things to get into is for our Quadtree grid that we're going to be using, we need to define where we're going to have resolution of a certain size. And so with Quadtrees and CMS Flow, we typically use Quadtree grids. And so that's all done with polygons. And so what we would do is in every area that we needed to add resolution, we would define a polygon, select that polygon, and add a value in there that basically says what the cell sizes are going to be inside of that cell. And so this is just one example of this case that we have here. It's our final resolution that we used for a certain project. Actually, we used a couple different ones, but this was one of our more detailed. I just wanted to show what it looks like. So in here we've added resolution along every groin field, around the jetties, in the areas of constriction through this little entry into a little bay. Also up here we've added zones for how narrow this channel is into this back part of the bay, things like that. In certain areas that are flat and we have tidal flats, we don't really need a lot of resolution, so we can add zones to decrease the resolution in those areas. And so I'll just show how this is done. So to get started, we don't have all of this yet. All we have is a blank canvas with a Quadtree in it. So one of the things that it may be nice to have is a starting point. So we already defined a shoreline when we did the activity classification. And so it would be nice to be able to use that and take that shoreline and add it to the Quadtree generator. So we have something to start with. But unfortunately, the merge for coverages right now does not allow a copy of a grid frame from the Quadtree generator. They're fixing it, so hopefully in 1309, 13010, something like that, it'll be available again and we'll be able to use that. But for right now, we have to go with a workaround. So what we can do is to just right-click on the activity classification and duplicate it. And so that will create a new coverage in the map module that basically, it doesn't know what to name it, so it just has the same name with a 2 at the end of it. And if you already had a second one, then have a 3 there. So you would just want to create that duplicate of the activity classification. Then you would change the type of that classification. So you would right-click on it, go down to Type, choose Generic, and then come in and make sure it's a Quadtree generator type. And then you would want to, one thing that you would do is to just come back in, and what I would do is just get rid of the old Quadtree generator and then work only with this one. So you can rename this. So what we can do is just how we did it earlier, just create a new grid frame that matches the old one. And so I'll go in and show you how to do that. But there, just basically create a grid frame, click 3 points, and then select the properties and enter the old values. That's the easiest way to do it. It does not have to be anywhere, take as much time as it did before. So just, like I said, click it out quickly, use the old values, and you can either, you had written those down, or you can go back in and see what the values for the origin, angle, and offset values are. And then just enter those, click OK, you're ready to go. And then, just like I said, delete the previous coverage and rename the new one. So you come back in and it's named Quadtree generator again. So, and then you have a starting point. You have an actual arc here along the shoreline that you can start with when you're wanting to define these zones. And so what I'm showing here is just a few rudimentary zones just starting out. So I've created one, my first one here around where the ebb jet will be coming out. So I've just made a little semicircular one here, connected it back to the shoreline. I've created another one from this island through here a little bit that I'm going to be setting a 10-meter resolution. And then this is a little tidal flat area behind this island and out here. These are going to be 20-meter resolution, and then some others that may be 40-meter resolution. And just click out and create a few of those. And once you're comfortable, you don't have to do it all at one time. You can do them piecemeal. But once you've created a few, then you would go up to the top of your frame and click Feature Objects, then Build Polygons, and then you would be able to select each one of these. And once you select it and right-click and go to Attributes, you'll be able to turn on specification of a grid cell size. And you would want to do this for any areas that are contained within the active classification, so where you would have water. It doesn't matter what the size of the polygons are for land cells, since they're not in the computational area. And so it doesn't make sense to turn this on and assign it at all. But for out here, I would definitely do that and select and do as many as you think are necessary, and then go through and I'll show you how to create a grid and see what it's going to look like. And if it is not what you want, then you would just delete that grid, come back into this coverage, and then add more zones of resolution and change it and fine-tune it to be exactly how you would want it. So when you're ready, as I said, just try to convert and create a Quadtree grid. And so, of course, you would want to save your project first, that way you don't have to redo all of those polygons. But just save your project and then come in under Convert and then go to Map to Quadtree Grid, and you'll bring in this dialog, which looks exactly the same, except now it's got more information down here. And so it says that the target minimum cell size is 2.5 meters. What that means is you have at least one polygon that you created with a 2.5 meter resolution. And you can't change these values in that spot. You'd have to go back to that polygon and specify a larger value if that was too small. But what you can do is come in and define what the maximum cell sizes will be for your grid. So areas outside of where you have resolution zones, you can specify to have a set cell size. So these are areas in the offshore that are deep water or in the corners. And I've set right here 160 meters. But basically that is defined, all of these sizes are defined by whatever the minimum cell size is that you're using for your resolutions. So if you have 2.5 meters here, the way the Quadtree grid cells are made is you combine 4 cells into one larger cells, and so essentially the spacing for that cell doubles every time. So in this case you'd have 2.5 to 5, 10, 20, 40, 80, and then 160. And so that's where that 160 came from. If you don't want to figure out this maximum cell size, you can put in an approximate number. And so if I had put in 180 here or 200 meters, what I would do is just click this adjust button. And then based on this cell size, it would bring it down to the next lowest cell size that matches up with the way the cells have to be, halves and doubles of each other. And then what we would do is come in and make sure that we set where we're getting the bathymetry for that. So you would come in and choose scatter set, select your one. And we've only got one scatter set loaded, and so that is the one that we would choose. I'll go into this in the demo and show you basically what this looks like. So once you click OK, you'll come back out and a grid will show eventually that basically is your Quadtree grid. And so you see how that looks here. And so this is for that one case where I showed you the final resolution, the really intricate cells along the growing fields and everywhere else. And you can either use this or not. If it's not good enough or you have too much resolution in some areas, you may want to come in and remove some, like lower the values a little bit. So just keep iterating until you get to a grid that you are comfortable with using. So some tips for generating telescoping grids. You want to have at least a couple of rows from one zone to the next before you transition. So you see here I've got a wider area, and out here it's a little bit smaller or fewer number of cells anyway. But you need to have at least, say, 4 or 5 cells in every area as you transition to areas of larger cells. It's not as important in some other areas, like showing here for the land. It's just gone from what I've defined out here all the way up, and it's quickly going. But these cells are never in the computation, so we don't have to worry about it. We do have to worry about it in areas with water. So just be aware of those transition areas and make sure you have adequate resolution to have the processes that need to happen. Another thing is channels with substantial currents. They need to have at least a set number of cells to transport water and be able to have the variability across the channel to define your flow. And so you need approximately 8 to 10 cells and stronger channels. Some areas you may be more comfortable with 20. Some you want to have 6. It just depends on what's going on. If you start running your model and you see it always blowing up in your channel, you may want to add some resolution and make sure that it has enough to go with. structures with for variable morphology, so rubble mound jetties and breakwaters and things like that. You need to have resolution surrounding that defined area, and so just keep that in mind. And areas that would wet and dry pretty quickly, or with sediment transport movement, just be cognizant of those areas and make sure that they're resolved as well. So that's about it for this video. I'm going to go, the next video will be a demonstration of all the techniques that I've shown here. So we will see you then.